Hi, I'm Arnie Gundersen from Fairewinds. Little change of venue today. There's been some reports in the press about a hydrogen buildup inside the containment at Fukushima, and along with that hydrogen gas, there's a discussion that there's some radioactive isotopes that are in the containment that could only be caused by a fission. Well, I thought I'd simulate today what a hydrogen buildup inside a containment looks like. Now, we're going to use this bottle as a containment, and I'm going to generate hydrogen gas in this little flask. Those nails are coated with zinc, and I'll add some acid to the zinc, and we'll create hydrogen gas out this hose. Put the hose in the bottom of the bottle, and hydrogen, being lighter than air, is going to push all of the gas out of this bottle. We'll be left with a bottle full of hydrogen. All right, let's see what happens. This is something you shouldn't try at home. I'm wearing gloves, and we've got a fire extinguisher in the corner as well as bountiful water, just in case. Again, don't try this at home. All right, here's our beaker. And this is muriatic acid. And those bubbles are hydrogen gas bubbles. That are filling this containment, this bottle, with hydrogen. Now we're going to wait a little while here for this bottle to completely full. Again, hydrogen's lighter than air, so it's going to float to the top. And then it's going to gradually push all of the air out of this container. Now we've waited about 4 or 5 minutes, and this bottle should be filled with hydrogen gas. All those bubbles ran out that hose and filled this bottle with hydrogen gas. All right, I'm going to take the hose out and set the acid aside, because the next part of this lab is inside the bottle. All right, now hydrogen gas is lighter than air. So we put it in the bottom, but there's no place for it to go at the top, so it's going to stay in there. It's not going to leak out. Well, now I've put a little hole in the top of this bottle, and I'm going to light it with a match. Now what's going to happen is you're going to be seeing a little tiny flame up here, and that's the hydrogen gas escaping. It's barely visible, and I'll try to enhance it in a minute. Now there's a little flame at the top of this. It's made of hydrogen gas, pure hydrogen gas. You can see I just lit this. You notice the bottle is not burning. It's just the very tippy top of this. That's hydrogen mixing with the oxygen in air, forming that flame at the very top of this bottle. Now, well, that's a hydrogen deflagration. That's the smaller of the two shock waves. That's what happened inside Unit 1. When you get oxygen coming in and hydrogen in just the right amount, 2 to 1, they combine to form water vapor, and they create a lot of heat and an explosion. Now, what's TEPCO doing to avoid this? The containment is leaking. We know the containment is leaking. Well, instead of allowing oxygen to leak in, they're adding and adding and adding nitrogen inside this vessel. So the hydrogen's at the top, but they're not allowing the oxygen to get in because they continually add nitrogen to the vessel. Nitrogen is inert. So as long as the inert nitrogen and the hydrogen exist inside the containment vessel, then everything's going to be fine. The gases from our experiment were generated chemically, but of course in the nuclear reactors, the chain reaction and the radioactive decay creates hydrogen gas. So that part of the lab is different, but the containment is just the same. It's just that TEPCO's containment is a couple million times bigger than my soda bottle. As a reminder, this November we're asking for your financial support so we can continue our educational efforts. For those of you who've gone to the Fairewinds website and found the donate button and clicked it, thank you very much.